Hello, my name is Alex Leach. My student number is 123456. This is assignment 1 for the nutrition module for the BTEC Level 3 Extended Diploma in Sport and Exercise Science. This presentation is going to be on nutrition and digestion. So we have 7 key nutrients in the body which I'm going to discuss for you today. We've got carbohydrates, fats, protein, vitamins, minerals, fiber, and water. And I'm going to talk about the role of the different nutrients. I'm going to talk about things like the different functions that they do, where you can get food sources and things like that, and how you implement them into your diet. So first I want to talk to you about carbohydrates. The main role of carbohydrate is that it's an energy provider for the body. And it's something called a macronutrient. A macronutrient means we've got to eat lots of them. Due to this, we require 50 to 60% of our whole diet to be purely carbohydrates. 1 gram of every carbohydrate will give us 4 kilocalories of energy. We got 3 different types of carbohydrates. You've got the monosaccharide, the disaccharide, and the polysaccharide. And the mono and the disaccharide are known as simple sugars. This is because they got no bonds or just a singular bond between the sugar molecules. So they get used up really, really quickly because you've either got to break no bonds or only 1 bond. Polysaccharide is where you've got many sugar molecules interlinked. Now, because there's many bonds here, it takes longer to break them down, so they're more fulfilling. So you've got food sources for polysaccharide are things like pastas, oats, rice, whereas when you look at the simple carbohydrates, things like pure sugar, honey, jam, these are the food sources. Fats is the next one we're looking at, and again, this is another macronutrient. They have many roles in the body. Roles will include things like an energy producer again. It allows the uptake of fat-soluble vitamins. It allows us to have healthy skin and healthy hair. It's part of the structural material for cells. It actually adds taste to food, which is really, really important. It helps with essential fatty acids. Many, many roles fats has, so it's a really, really important thing to have. 30 to 35% of our diet should include fats. So like I said, it's a very, very important nutrient, and it's a macronutrient, so we need lots of it. 1 gram of fat will actually give you 9 kilocalories of energy. We got 2 types of fats, so we got saturated and unsaturated. Now commonly saturated is known as bad fats, whereas good fats are known as unsaturated. If you were to have saturated and unsaturated fats at room temperature, you'll notice that the unsaturated fats tend to be an oil, they tend to be a liquid, whereas the saturated fats tend to be a solid. You get your saturated fats from animal products, so a lot of animal fats like butter and lard are saturated fats, whereas things such as olive oil, nuts, avocado, all these things are unsaturated fats. A couple of roles in this set of fat is thermoregulation is a really, really important role for fat as well. Protein. Protein's main role is for growth and repair. However, it can also be used as a secondary energy source. We've got 15% of our diet needs to be protein. 1 gram of protein equals to 4 kilocalories of energy. So this is a secondary energy source, but it'll be used as a last resort. You'll use fat and carbohydrates first. We've got amino acids which build up protein. They're known as the building blocks. So you've got 20 amino acids altogether. You've got essential amino acids and non-essential amino acids. So the essential amino acids, there's 8 of them, and there's 12 non-essential. Now they're called non-essential because we don't need to intake them in our diet. Our body can actually make them. However, the 8 amino acids our body can't make. Therefore, we need to intake this with our diet. That means with our food sources, we have complete and incomplete proteins. Complete proteins include all 20 amino acids, whereas incomplete do not contain all 20. Food sources of food examples of complete proteins, things like meat, whereas incomplete protein can be things like fruits and vegetables. Right, moving on now to vitamins. Vitamins are known as a micronutrient because we don't need as much in our diet. So we have 2 different types of vitamin. We've got fat soluble and water soluble. So the fat soluble are A, D, E, and K, whereas the water soluble are B and C. So the fat soluble are stored in the body and they're stored in the fat tissue, whereas water soluble vitamins can get excreted within the urine. So if we look at the fat-soluble vitamins first, we've got vitamin A, and we need 0.7 milligrams a day. So it's really good for sight and for your healthy skin. You can find that in dark green vegetables. A deficiency is something which, if you have a lack of, it's a consequence of that. So if you have a lack of vitamin A, you have reduced night sight and rough skin. Next one is vitamin D. So that strengthens bones and assists with muscle contraction. That's because it assists with calcium absorption. Calcium plays a massive role in muscle contraction, as shown in the sliding filament theory. Sources include egg yolks and liver. However, you don't actually need to intake this because it's known as the sunshine vitamin. Therefore, you should get enough just from sunlight. Deficiency is weak bones. Vitamin E is used to protect the cell walls, and you can find it in nuts and seeds. And if you don't have a good intake of vitamin E, you have nerve abnormalities. You need 4 milligrams a day. Last one is vitamin K. You need very, very minute amounts of this. You can see 0.001 milligrams per kilogram of body weight. Excuse me. And it assists with blood clotting. So obviously a deficiency is defective blood clotting. And you can find this in milk and cabbage. Final two vitamins, we've got a B and C, which you need in quite large amounts of this because you can't really store them in the body because they get excreted in urine. Vitamin B is largely used in energy production. You find it in meat, milk and vegetables. You get muscle cramps and loss of appetite if you don't have enough. Vitamin C forms a part of the immune system, and you can find it in fruit, most specifically oranges. And you can have deficient immune system, but you can get scurvy, which is what sailors used to get, like bleeding gums. Minerals, we got two different types again. We've got macro and trace. So the macro minerals are ones you need more of, whereas the trace minerals you don't need quite as much of. So we go through macro first. We've got calcium. You need 1200 milligrams a day. Really important for bone formation and muscle contraction, as discussed earlier in terms of calcium. Find it in milk, and the deficiency is loss of muscle contraction or weak bones. Next up is potassium. Potassium is found in banana, is really important for nerve impulses. However, you get reduced coordination if you don't have enough potassium. You need 1 gram a day. Sodium, big role in water balance and is commonly known as table salt. You get dehydrated if you don't have enough. You need 5 to 10 grams per day. Then we go to the trace minerals. So we've got zinc, 12 to 20 milligrams a day, which assists in carbon dioxide transport. That you find it in cheese and it's reduced respiration. Oh, sorry, not 12 to 20 grams as milligrams. Magnesium, 5 milligrams a day. Really important role in the reproductive functions. Found in peanuts and kidneys, and deficiency is reproductive failure. Iron is the formation of hemoglobin, really important. Found in liver and eggs, and deficiency is anemia. 18 milligrams per day is required. Now, if we look at fiber, you need 18 grams of fiber per day. We have two types. You have insoluble, which is found in things like oats. Insoluble fiber cannot dissolve in water, and it helps your digestive system. And then you've got soluble, which can dissolve in water, and is found in vegetables. Now, what this does is it stops the uptake of all nutrients. So it's really clever in terms of weight management, because you don't have to uptake so many nutrients. And finally, we've got water, and we need 6 to 8 cups per day. It's got a few roles. Plays a big role in thermoregulation when we sweat. Big transportation system within the blood, and also helps the digestive system. We get it from our drink, so we need 1200 milliliters per day. Get it from food. However, we also get it from metabolism, because it's a byproduct of the aerobic energy system. Right, I want to now compare a marathon runner to a weightlifter and look at their diets. So rather than looking at average amounts, I've changed the amounts they need. So I said a marathon runner needs 70% carbohydrates, 15% fat, and 15% protein. Now, the reason I've increased the carbohydrates so much is because the marathon runner needs to run for at least 2 hours. The world record for marathon is just under 2 hours. So you need massive amounts of energy for this to be able to run for 2 hours. Therefore, we need a lot of carbohydrates. And more specifically, we need complex carbohydrates to break down slowly. However, with things like a sprint finish, we will need simple carbohydrates, and they will eat simple carbohydrates along the way with glucose gel packs. But carbohydrates has to be the most at 70%. Protein, while they're training, while they're running, they're going to have a lot of growth and repair needed due to all the muscle fiber tears and things like that. Therefore, protein's still really, really key for a marathon runner. Like I said, you're running for over 2 hours, so you're naturally going to get muscle tears. Therefore, protein is definitely key, and I didn't want to reduce that, so I kept that at 15. Consequently, fat had to be reduced to 15 because obviously, in terms of percentage, it has to add up to 100. 15% is the minimum I wanted to go with fat because it plays such an important role. It's going to play an important role in terms of energy production with different aspects, such as thermoregulation, and like we said, adding taste to food, healthy skin, and the marathon runner still really needs that, and specifically with things like cellular structure to stop cells getting damaged. Now, in terms of other aspects, I really think a marathon runner could really use with sodium in the diet because sodium stops dehydration and helps water balance. Marathon runners are going to be requiring a lot of fluids. They're going to be transporting oxygen all around the body and all the energy. So they're going to make sure they got enough water to do that effectively to get the energy to the working muscles. Also, if a marathon runner gets dehydrated, performance levels will decrease rapidly. Another mineral I think they could use is zinc. Zinc plays an important role with respiration because it assists with carbon dioxide transport. So it helps get carbon dioxide away from the working muscles, getting rid of all those waste products to allow the marathon runner to run as effectively as possible. An obvious vitamin I think they need is vitamin B. Vitamin B plays an important role in transport and production of energy. Energy is so important to a marathon runner. Without the right amounts of energy, they're not going to complete their race properly. If they can't complete their race properly, or to the best of their ability, it's going to severely affect their performance, and they're not going to win the races like they need to. Vitamin D, I've got because it helps with calcium absorption. Calcium absorption is massive. In terms of the sliding filament theory, calcium actually helps to show the binding site for actin-myosin to enable those muscle contractions to take place. If a marathon runner doesn't have calcium, they can't contract their muscles properly. They're not going to be able to run properly. They lose technique, and therefore they won't be able to run as fast, negatively affecting their performance. In terms of fiber, a marathon runner doesn't need more than 18 grams a day, so it won't actually affect their performance, but they still need the recommended daily allowance to stop things like stomach upsets and things like that. Water needs to be significantly increased. I recommend between 3 to 4 litres a day from the recommended 2 litres that we mentioned earlier. Just because water's a transportation mechanism and it is a massive thermoregulator for the body. If the marathon runner can't transport energy and things like that towards the working muscles, and it cannot get rid of the waste products away from the working muscles, and the marathon runner cannot thermoregulate properly, that marathon runner is not going to be able to keep up their performance levels, and they're then not going to be able to win races or run to the best of their performance. And now moving on to the weightlifter. So the weightlifter, we've reduced carbohydrates down to 55%, reduced fat down to 20%, and we've actually increased protein up to 25%. So carbohydrates still needs to make up the most of the diet again, so we're still taking over half of the diet. It's because energy is so key in any sport. A weightlifter clearly needs energy to actually lift the weights, but it's really key in terms of everyday life, and not only that, in terms of their training as well. If they can't train effectively, they're not going to make the right training gains in order to compete in competitions properly. Now, in terms of competition, they're going to need a lot more simple carbohydrates. Now, compare this to the marathon runner. The marathon runner is running for at least 2 hours. A weightlifter is performing a quick movement, which is going to be over in a matter of seconds. Therefore, simple carbohydrates are key here. Um, when we look at fat, fat has been reduced again from the average amounts. However, still plays a key role in the body, which is why we didn't want to reduce it too much. Specifically for things like structural material or cells. Think of all the stress that the weightlifter's putting on themselves. You want to know that their cells are going to be structurally sound. There's going to be nothing wrong with them. Therefore, if we have enough fat, we can make sure we protect them while weightlifting. And now looking at protein, this is probably the key macronutrient for the weightlifter, and that's because of the main role of protein, which is growth and repair. The weightlifter needs really strong muscles, therefore they need to grow their muscles. technically the more muscle mass you have, the more strength you have. I know it's not in turn necessarily that easy, but in theory, that should make sense. Also, when they're in training, they're ripping a lot of muscle fibers all the time, and they need to repair these effectively. Therefore, protein will allow for this growth and repair to happen. If this growth and repair happens effectively, it will definitely benefit the weightlifter's performance, and they'll be able to lift stronger, heavier weights. Excuse me. If we look at the micronutrients, in terms of vitamin D, that would be really, really important for the weightlifter. Discussed it in terms of the marathon runner for things like muscle contraction, but if we think about strong bones for the weightlifter, they're putting their bones through a lot of force. Therefore, they need an incredible amount of bone strength and density to withstand that extra force from the weight to protect those bones so they don't break. A similar vitamin is vitamin E, which protects cell structure. Now, we talked about this a little bit with fat as well. Weightlifters put their body under loads and loads of stress by lifting incredible amounts of weight. They have to protect their cells, their structures throughout their body. So by having this vitamin D and vitamin E, they're protecting their bones and their cell structure by doing this to allow their body to function normally. As long as that happens, that allows them then to compete naturally and to perform to the best of their ability. In terms of actual minerals, I think potassium is really important because it allows for effective nerve function. Now, if you think a clean and jerk or a snatch, they're really, really skilled movements. Now, if your nervous system isn't working properly, you're not firing off all those neurons effectively, and you can't produce a skill properly. Therefore, the effective nervous system production is required to allow for effective coordination. And again, calcium is really, really important in terms of muscle contraction. If you can't contract your muscles properly, you can't train properly, you can't perform the skill properly. Calcium is really, really important to allow for those strong muscle contractions to take place, so the weightlifter can lift the weight over their heads and perform to the best of their ability. Fiber again, like the marathon runner, doesn't need to be increased. 18 grams again doesn't have any impact on performance. Water needs to be increased from your average 2 liters a day. I wouldn't increase it too much, maybe 2.5 max. Like I wouldn't go as high as a marathon runner's 3 liters. 2.5 liters is required because they're still doing physical activity in the training, so they're going to need the increased amount of water to ensure for things like thermoregulation and transportation of nutrients, energy to the muscles and waste products away. However, they're not working for as a prolonged period of time as the marathon runner, therefore they don't need as much water. Now what I want to do is discuss the digestive system. First of all, I want to talk about the 3 roles of digestion, which are digestion, absorption, and excretion. So digestion is merely the breakdown of food. So food's obviously in big chunks, big quantities. We need to break that down so it's manageable for the body. So that's what digestion is. Absorption is once that food is broken down, we absorb the nutrients into the body. So the useful things are in food that the body needs, we're going to absorb. And finally, excretion. So there's waste products left over once we've eaten food. Excretion is just the elimination and the removal of these from the body. Right. The anus is the end of the digestive system. This is where excretion finally takes place and the waste products get removed from the body. Pancreas, by here. Pancreas produces digestive juices, which helps in the digestion of foods and the breakdown of foods. Gallbladder here, it stores concentrated bile. Bile is one of the digestive juices which helps to break down the food. Duodenum is this tube here which goes from the stomach down to the small intestine, and it is the passageway for food to get from the stomach to the small intestine. Liver here, so this makes the pancreatic juices which are used for digestion. The esophagus is the food pipe here. So the esophagus takes food down to the stomach, and the way it does is it pushes food down using this wave-like motion known as peristalsis. The large intestine here, when food, well, it's called chyme, when chyme gets to the large intestine, it's now just indigestible matter and fluid, so it can absorb the water here, but then what it does is it passes the indigestible matter onto the rectum. The rectum here is just for the anus, so it just collects the indigestible matter before pushing the waste through to the anus for excretion. The stomach here is like a large mixing bowl. This is where chemical digestion happens. Chemical digestion is where we utilize chemicals to break down food. So it just churns the food, and this is where it's churned into our liquid known as chyme. Small intestine is here. The small intestine has finger-like structures on it called villi. Now this is used to increase the surface area. So this is where absorption is going to happen. And the absorption here is of the main nutrients into the bloodstream so it can be utilized by the body. And this is the mouth. In the mouth is where mechanical digestion happens. So this is the grinding of the teeth by chewing on the foods. Now in the mouth we produce saliva, which can start to break down starch. So mechanical digestion happens here where it actually starts to break down starch. It's in the stomach where we actually break down the other macronutrients. Thank you for watching my presentation.